This video explains how to use PCT to set up a zoning system based on the FXPC controllers. The system uses a modified mixed-error single-path standard application that is loaded into a PCG for the air handler and a modified standard fan coil application for the zone damper that is loaded into a PCV controller. Now these applications were created in PCT 10.0. So anything prior to PCT 10.0 will not support the new application files. The zoning systems library contains 21 different application files. There's one application file for the air handler and 10 application files, two groups of 10 application files for the zone dampers. One of the groups of 10 is for air handler supplied heat only. The other group of 10 have outputs for proportional reheat or on-off reheat. Each group of 10 have pre-addressed MAC addresses and pre-addressed device IDs. There are also independent peer-to-peer communication settings for each MAC address. MAC address 5 will be communicating with zone 1, MAC address 6 for zone 2, 7 for zone 3, down to 14 for zone 10. If you have zones with no reheat, you would pick CAF files for that application. For zones that do have reheat, you would pick a CAF file with the reheat option and then mix and match them. Now let's go to the air handler and open up the CAF file. The air handler application was created to support between 1 and 10 zones. If we look at the network inputs, you can see that zone 1 through zone 10 are listed. Each zone sends its demand, its occupancy mode, and its zone temperature using peer-to-peer communications to the air handler. The zone demand is run through the zoning authority module. This module calculates the highest cooling demand and the highest heating demand and sets the mode of the air handler to be either heating only, cooling only, or fan only. This mode is then sent out to the dampers using peer-to-peer communications with the summer-winter network output and the system mode network output. To allow some control from a network, if you go to the application mode and send this unit into fan only, cool only, or heat only, the air handler will respect that input and then send that same mode out to the damper controllers. Now, the second input is the zone occupancy demand. The zone occupancy demand goes to the zone effective occupancy. Each of the zones is set up to use a warmer cooler input and temporary occupancy. So if somebody comes up to the dial on the network sensor, they can put the zone into standby. If you adjust the sensor so the zone goes to standby, that will be sent to the air handler using the peer-to-peer communications. And when one of the zones is in occupied, the air handler will follow suit. The last input is from the zone temp. The zone temp is run through the night fan operation. Night operation for the air handler is to shut down. If the coldest zone goes below 60 degrees, again, this is adjustable using other network variables. If it goes below 60 degrees, the night fan will come on and supply heating to the zones. If the warmest zone goes above 85, the night fan will come on and supply cooling to the zones. Now, in our application here, we're going to only set up 2 zones. So my first step is to delete all the zones that we're not going to use. They can stay on the application file. However, if you leave them there, they will come up on the graphic that you automatically add from the supervisor. So I'm going to delete everything but zone 1 and zone 2. And now this application is set up to be a 2-zone controller. Next, let's look at the outputs. You can see that we have a bypass damper output. We support 2 stages of cooling, a packaged economizer, or a mixed air damper, 2 stages of heating, or a proportional output for a hot water valve, along with the supply fan control. Now in this demo, we're going to go ahead and use mixed air control and 2-stage heat cool and 2-stage heat. So I'm going to go and delete the packaged economizer output and the reheat output. We can also convert this application to 1-stage heat or 1-stage cool. That would be achieved by deleting the stage 2 cool and the stage 2 heat, then going to the MSC staged cooling output, going to the details page, and then going into that and disabling stage 2. We want to accept that because we're going to have 2-stage heat, 2-stage cool in this operation. Now, I also created a discharge air mode select module. And in this application, I have the opportunity for you to select discharge air control. So the DA control select, discharge air select, in the details is false. So if I want to control a discharge air reset schedule, I would simply come over here and turn this default to true. I can also do this from the network. Now, the way it comes standard is to control the staged heating using a zone 1 damper set point along with a differential. So the zone 1 damper set point is set up to turn on either stage 1 heating or cooling when the zone demand gets up above 40%. And the zone demand stage 2 was set for 60%. Both of these settings are adjustable, and the stage differential can also be adjusted, which is set for 25%. And we can go ahead and expose that to BACnet also, if we want. Now, our next step is to define the hardware. This application comes set for a PCG controller. My hardware is a PCA controller. So I will hit Define Hardware, change it to the correct PCA controller. I can change the name now if I so choose. Now, since I changed the controller settings, the network settings will change. However, this one is factory set to be device address 4 with an instance number of 1004. It's very important that the instance number stays at 1004, or all the peer-to-peer communications would have to be updated for each of the zone controllers. So this is fine for me. Again, it's going to be MAC address 4 with an instance number of 1004. I can then save this, and I'm going to save this to my desktop. And we'll go ahead and just call this demo. Now I do have these controllers on a network, and right now they're just sitting there, and I can go ahead and load that app file using the BACnet routing option. Now that our air handler is downloaded, we can go ahead and start working at our first zone damper. Now, I have two choices. I can load an application that contains proportional and on-off reheat, or another application that only provides heat through the air handler. In this particular application, I will use the proportional reheat, so I'm going to open up the PRH5. Again, this is for MAC address 5. These applications come set for on-off reheat or proportional reheat. So we pull this down, you can see that there's a C for the controller output and an O for the output for proportional. Since we're going to use a proportional output, I'm going to delete the C, the controller output. If I left it here, we would actually have both objects layered on the graphics, and it could be pretty messy. Now let's take a look at the zone demand here. The zone demand, if I view the details, you can see is set up to peer-to-peer communicate to device ID 1004 and send information to AV10188 in that controller. The 10188 is the backoid. Same thing for the effective occupancy. It sends it to backoid 10243, and the temp chair is being sent to 10305. Now, these 3 points, the outputs from the zone controller, push their data to the air handler controller. The summer-winter input pulls the data from backoid 10223 in the device ID 1004. And the same happens to the system mode. Again, if I go to define hardware, the default is PCV 1630, which is what I'm going to load this into. And the network settings are pre-adjusted for you, and device ID 5 and the instance number is 1005. And now we can go ahead and load this after we save it to the desktop. So I'll go to the desktop and save this. And now I can load that into my PCV 1630. Now, last, we need to choose a application file for Zone 2. And Zone 2 will have no reheat, so we'll use the air handler only heat option. Now, when there's air handler only heat, we really don't have to change any part of the application, but we will go to define hardware. Now in this case, I want to go and change this from a PCV 1630 to a PCV 1615, since that's what I have. And whenever I change the target device, I'll have to go to the network setting and change the MAC address. The device IDs changed, stayed at 1006, but the MAC address went back to the default of 4. Now that that's done, I can go ahead and save this. And load it into my hardware. Now, since these are set up to be peer-to-peer communications, as soon as the download is completed, all that data is automatically being pushed or pulled into or from the air handler controller. So as soon as the download is created, we should have an operating system. May have to adjust some of the different settings, but the communications should be automatically set to start up. All right, so now that it's done, I'm going to open up the desktop application that was loaded into my PCA and go into the commissioning mode. Now, as soon as the data is updated, we can go into the network input page and see that these peer-to-peer communications have already started. And you can, as you can see, here's Zone 1 demand, the Zone 1 occupancy, and the Zone 1 temperature. Same things there with Zone 2. So now we can stop commissioning, And this has been a video on how to use PCT to set up the PC controllers in a zoning application. On the next video, we'll go over how to use FX Workbench 5.2 to create graphics and ensure that the peer-to-peer communications between our zones and our AHU aren't interrupted.